lot of different things going on. But yeah, I think this first one's pretty much done, except that I think they said, yeah, you have to do good error handling. Yeah, so let's see. And is this the one? Actually, let me double check. Let me check what I changed. Yes, so that's the one I had sent, right, with the corrections?
Oh yeah.
Okay, cool. Yeah, it looks like that should work. I don't know if you want to try running it or whatever, but it, it worked when I ran it. Oh yeah, and then you need to run it from the command line with input arguments. I think it was, yeah, you need to specify, what was it, the file to read from, which would be frames2.dat, and then the file to write to.
Which one?
Yeah, so you need to, if you remember, you need to run this. Basically, you need to, yeah, run this on the command line. Oh, let's see. You also might need to, yeah, if that's just in your downloads folder, you might need to put it in the same folder as the input file. If you remember, like this one takes an input file, so might need to put it where your other stuff for this problem is. Yeah, I don't know. Okay, yeah, there you go.
Oh, no. I think it's here. Okay, and now we do this, right?
Well, I mean, you gotta wait a minute. So, uh, but the one I sent you is still in your downloads, right? Or did I wait? Did I miss you moving that into the folder you're in now?
Nope, it's still there.
Okay, yeah. So yeah, if you want to try moving that into the, yeah, that folder.
Yeah.
Okay, yeah, it should be fine to overwrite them. I've got your original from last time anyway. If you need a copy of the old version. So yeah, it was just a matter of, I think, replacing fscanf with fread, and I think there was like one other bug I fixed that I forget what it was, but it was small. Um, okay, so yeah, then if you run the program, then you need to give it, after you put the name of the program, yeah, you need to put the name, the name of the input file, frames2.dat, and then the name of an output file like output.txt or whatever you want to call the output file. Okay, that seems to have run. It runs quickly, so then if you look at your output.txt, it should be correct.
Yeah.
Interesting. Wait a minute. Is that? That looks correct so far. Um, Interesting that it. I mean, mine gave much longer output than that. So I'm not sure what's up with that. Let me actually take a look at my output because you've got text RWZI, WTGV, RVB, 75730, 95010. That's interesting. So, I mean, yeah, you've got like the first 9 rows exactly the same as I have them, but I have About 100,000. Yeah, in fact, exactly 100,000 lines of output. So that's a little odd, actually. I don't know why it died after 9 lines on your side there. Um, maybe try, if you want to close that, maybe try running it again just to make sure. Maybe it was just some fluke. I don't know. That's very weird. Um, and in your frames2.dat file, is that like, let's see, how big is your frames2.dat file? Well, okay. Yeah, I mean, that's going to look like nonsense, but yeah, it's definitely longer than what we printed out. Okay, that's a little bit odd. Um, not sure what's up with that. Okay, well, maybe we can try finishing the error checking, and maybe that will give us some hints.
Can I go to the bathroom real quick?
Sure, yeah, take your time.
About that?
Okay, no worries. All right, so let's see. Yeah, I'm not sure why this is why it's being weird, but I guess we, like I was saying, I guess um, we can go ahead and finish the error checking and everything, and then see if that's still acting funny. Because yeah, I think the note at the bottom says, yeah, after the while loop, we need to check for errors, close the file, and clean up the memory. So yeah, I think that's all we've got left to do. Um, and I think, let's see, we've already got closing the file for writing, so that's set. Um, oh, right. So I think the other thing that we were saying we would do is, let's see, so we're doing an F read. So yeah, I guess the question is like, how do we check for errors in an F read? And I believe, let's see, I just need to check and see if, actually, I'm not sure if F read, if we will know for sure. Because when we were using fscanf, we had an explicit like error code, but F read, um, yeah, we might not be able to. Um, let me see if we can check for failure codes. Okay. Oh, actually, I guess let's see. Yeah. So okay, I guess we can check FEOF and F error. Let me just. That's one I haven't really used, but let's see. Okay. Um, so I guess let's see. So I guess we can check. I guess we would probably want to check F error first, just to check and see if there's an error reading the file. Let's see. So let's see. Okay. Yeah. So we can actually. It's just a couple lines of code, I think, uh, to close things out or clear things up. So I think what we can do is after our F close FW line there, after 111, we can do a check to see. So we can say uh, if F error, FERROR, and that's a function. So yeah, put that parentheses after that, and we give F error our byte that we're reading, or sorry, our file that we're reading from, which I believe we called FR. Yeah. So if F error parentheses FR, um, and let's see, is not equal to 0. Yeah. Then we can print an error message. So basically, yeah, you can print a message saying, you know, do like a kind of what we did on like line 103 or whatever, where we just note that yeah, we print out an error message that we couldn't read from the file. And instead of write to, it would be read from in this case, I guess. Okay. Um, and I guess you can say, and then probably after that, if we want to follow that with an else if, um, and we can check FEOF. So you can say else if, and then in there you can say FEOF, and then give that FR. Let's see. Let me just see how we do that. Yeah. So I guess you want to, and then you want to probably have double ampersand to say um, and number of items read greater than 0. I think you want greater than. Yep. Because basically, yeah, that's a sign that. So you again probably similarly want to print with fprintf a standard error message saying something like, you know, end of file reached earlier or something like that. Basically, yeah, that's just a sign that you reached the end of the file prematurely. I think let me just double check. Actually, you know what? Let's let me just check something here. I just want to see if our previous error checking needs to be changed. Actually, yeah, we'll need to check some other stuff in a minute. But I think actually, let's change the greater than 0 actually to a not equal to 0, just in case. Yeah, because that should be the same thing. Yeah, okay. And then, okay, and then after this, I guess all we have to do is close the file cleanly. So that would be f close parentheses fr. And then I guess also if we want to be really good, we should clean up the linked list. So let's see if you've got a variable already declared that you can reuse. So let's see. Uh, yeah, so why don't you just declare a node pointer, call it temp or whatever. Um, yeah. Um, so, and then I think you can say while head is not equal to null, yeah, then we can go into a while loop here. And I think what you'll want to do is set temp equal to head, and then head equals head arrow next.
Yeah.
After on the next line, you just on the next line you can set head equal to head arrow next. Yeah, and then you can free temp. So yeah, that would be yeah, exactly. So what that's doing is just we initially set temp to whatever the current head of the linked list is. So we save the old head pointer, then move head to the next element in the linked list, and then free the previous element. And then yeah, I mean if you want to be explicit at the end, you can return 0, but I mean you don't have yeah. I mean that would be implicit, but you may as well. Yeah. Okay, so I think that's pretty good. The one thing I caught is that probably up above when I changed um, the fscanfs to freads, there's a couple of places where we probably want um, let's see. Oh, actually, you know what? I think we're actually okay. We're just looking at the semantics of what we said. Uh, yeah, actually, I think we're all right with what I was going to say. So actually, I think we're good. So I think you can try to run it again, um, and hopefully we'll see why you're getting that weird output. Oh, you need to compile it again. So you'll need to hit the run button up at the top to compile it. I think.
Maybe that's why it wasn't working.
I thought you did compile it before, but maybe I'm wrong. And then you can try running the command line version. And we can look and see what output.txt is now. Oh, I wonder if that, wonder if it matters if it's closed. That's very weird. I wonder if,
Can we come
what's the
back to this another day and just
Sure.
go to another problem?
Yeah, that's fine. I'm just a little perplexed by it because it worked fine on my machine. I'm not sure why it's being weird on yours, but in theory, the code should be
I
fine.
think
But okay.
I think Mac OS has a different is more thorough than a Windows. So I
Yeah.
think Windows is
Yeah.
limited.
Yeah. It's hard to say. Yeah, it's just weird that it
Yeah.
would do like 9 lines and then quit. But anyway, yeah, so that may be some kind of system error or whatever. But in theory, the code should be fine. I mean, I can double check it, but um, you know what we added was just extra error checking, so it should still be fine. Okay, yeah, we can move on if you're wanting to move on to another one.
Yeah.
Okay, any particular choice, or do you just want to go straight through to the next one?
Straight through.
Okay,
I'm
cool.
guessing
So
it's a little bit
that's
easier, this one.
yeah, 1B. Let's see.
Okay.
So we're running a program that generates an array with function pointers to the following functions from math.h. Okay. Um, generate a secondary array with the names of these functions. Allow the user to select which function call using a menu. Read a number and apply the selected function to it, then print the result on screen. Yeah, that should be okay. Let me check a little bit of syntax here because I've used function pointers, but okay, yeah, that's kind of what I figured. Yeah, the syntax for like function pointers is a little bit strange. But I've got it pulled up here. And let's see, they're doing this with sine, cosine, log, and squirt. And I'm assuming, let me just double check. So yeah, sine takes and returns a double. I'm assuming that's the case for all of them. Let me double check. Cosine takes and returns a double. Log. I mean, if I'm guessing what their intention was in creating this assignment correctly, they're all going to take and return a double. Yes. Okay. Yeah. All right. So first part of the requirement is write a program that generates an array with function pointers pointing to the following functions from math.h. So you'll have to include math.h. I guess that's the first thing. Um, yeah. Okay. And then inside main, yeah. All right. So the syntax for declaring, oh, okay. Yeah, the syntax for declaring an array of function pointers is a little bit weird, but so first so basically all of these functions take in and return a double. So the syntax for declaring the array of function pointers would be double, and then space, add opening parentheses, and then a star, and then whatever you want to call the array, you know, pointers or function pointers or whatever you want to call it. Uh,
Inside the parenthesis or outside?
yeah, right after the star. So yeah,
No, is the star inside the parentheses?
yeah, inside the parentheses. Yeah,
Just you said array.
yeah. So whatever you want to call, whatever you want your variable name to be called. Yeah, math array is fine. And then a bracket. Yep, and then a four because you'll have four functions. Yep, four inside the brackets. Okay, and then we'll go outside our parentheses, and then you'll have a space and another set of parentheses, um, and uh, and I believe, let's see, yeah, and then it'll just be double, and let's see, if I don't think it really matters what we call the argument, but us call it arg because that's what Squirt calls its function. So that's fine. Yeah. Okay, and that's good, and then a semicolon at the end of the line. So that's an array of four. Basically, what that's saying is that's an array of four function pointers where um, where they return doubles and take in doubles. With the sort of ordering of the like, I mean, all of the individual elements make sense, but the order is a little bit nonsensical, if you ask me. Okay, so then what we want to do is assign those four function pointers. So you'd say like math array bracket 0 equals, what's the first one? Sin, S-I-N. So you just, yeah, and you just do it like that. You wouldn't call, because if you put the parentheses there, it runs sine. But if you just put the name of it there, the name of the function acts as a pointer to that function. So exactly like that. Yeah.
Mhm.
And then you'll do the same with math array 1 equals cosine or cos. Yeah. And then math array 2 equals log. And math array 3 equals squirt or square root. Yep. Okay, just like that. All right. So now, oh, I guess they say generate a secondary array with the names of these functions. Allow the user to select which function to call using a menu. Um, so
Yes.
uh, let's see. I think we actually, I think we can do this in one line with an array of strings. Um, hmm. Well, actually, yeah. This should be okay. Yeah, I think the way to do it is probably make this a const. Uh, let me think about this. Yeah, okay. Yeah, so I think we can do, if we want to do it the easy way, you can, on the next line, you can declare a const char pointer. Well, so yeah, it would be const space char space star, and then whatever you want to call the array of function names, name array or function names or something like that.
Mm,
Yeah. And that'll be a bracket 4. Yeah. And then, yep, semicolon after that. And then on the next line, you can say um, name array bracket 0 equals, yeah, set that equal to the string sin. Yep. And then same, kind of repeat the pattern. Name array 1 equals cos, etc. Yeah. Okay, that should work fine. Okay. So let's see. All right, so then I guess it's time to display the menu. So you can just printf, something like select a function or something like that. Mhm. Um, okay, and then I guess probably if you want to write it semi elegantly, you want to you'll probably want to have like a little for loop. So you could do like a for loop from 0 to 3. Yeah, so for I equals 0, int I equals 0. Yeah, I less than, yeah, that's fine. Yep, and I plus plus, or I less than 4, either one. Yep, and I plus plus. And we can
Let's
print,
just do.
okay, yep. And then you can printf. I guess it depends on how you want to display this. I would suggest, I guess, probably inside printf, you just give it a format string like %d colon, and then %s, yeah, and then a backslash n, yeah, and then after the ending quotes before the parentheses, you can do comma I comma name array bracket I. But before name array bracket I, you want to do another parameter, which is just I. Or you could do I plus
Oh,
1 if you wanted to give them the choice of 1 to 4 rather than 0 to 3. Yeah. And you might want to put in your top line that you're select one of the following math functions. You might want to put something like select one of the following math functions, parentheses, 1-4 or something like that, just to indicate they're supposed to indicate they're supposed to type a 1 to 4. Yeah. Okay. Okay. That is that. And then we're ready to, I guess, read some input. Let's see. So I guess, mm, I guess probably the easiest thing to do would be um, get char, but let me see here. Yeah, I think this would be fine. So I guess because it's only going to be a single character, you can do, char and call it whatever you want, input or choice or something like that. And you could set that equal to get char, the function get char. Yeah. And then I guess we can, oh, let's see. Um, I guess we should check to see if the choice was no. I mean, they didn't really say anything too explicit about about what would be like valid numbers, but I guess you should check and see if, and you could say if choice um, is less than the character one, like single quote one, single quote, yeah, or so you want to, yeah,
greater
you
than
want,
4.
yeah, or greater than, yeah, the character 4, yeah. I mean, they didn't say what to do, so I would probably just print an error message and exit.
Yeah.
Print like, invalid choice and just exit. Oh, you can just do printf, I think. Well, yeah, because
Yeah,
this is
because it's
more
not
like
a
user.
pass.
This is not like a system error. This is more like user error. So you could just, yeah. Okay. And then, yeah, you can just exit. I would probably just exit with a zero code because, again, it's not like a system error. It's just incorrect input. But yeah. All right. So that gets us out of the, bad choice. Okay. And so assuming, otherwise, I guess they had a correct choice. So I guess the next thing to do is read in a double. So let's see. I'm trying to think about the easiest way to do that. Probably, probably scan F. Yeah. Um, yeah, I think that makes sense. Okay, so probably we want to printf, input a number or something like that.
How? One more time.
Oh yeah,
You're
just
breaking up.
yeah, we can just do a printf. Yeah, we can just do a printf and instructions to type a number to because we need to read a number for um, us to run the function on. So whatever you want, whatever instructions you want to give the user.
Can it be scanf?
What's that? Sorry, I didn't hear you.
Shouldn't it be shouldn't it be scanf since it's
Well, we
from the
will
command
eventually, but
line?
I'm saying like we should now put some instructions for the person to type
Oh,
a
okay.
number. Yeah, like and then we'll scanf. Yeah,
Yeah.
because they need to type in a number of some kind to operate on. Um, yeah, well, you can do that too if you want. Or when you said your choice, you mean you want to print out like what function they chose?
Uh, no, like when before you type in, I just 1 through 4. That's where. So here would be either one.
Wait a minute. I'm confused. What they're supposed to enter here is like a number to like take the sign of, or the log of, or the square root of, or whatever. Maybe I'm not understanding what you're trying to do there.
Oh, so it's not these.
Oh no, no, no. Yeah, we're done with that part. That part's all done. Now we
Okay.
need to
Okay.
ask them to type in a number to, like a number to take the square root of, or to take the log of, or whatever. Yeah, yeah. Because if we've gotten this far, they have made a valid choice. Um, yeah. Okay. Right, and then we'll do a scanf. So that would be yeah. So you'll need to right before your scanf line, you'll need to declare a double variable, or somewhere before your scanf line, you'll need to declare a double variable.
Yeah.
Um, let me just double check. I forget what scanf does if it fails. Let's see. Okay. I guess I wouldn't worry about it too much because I don't think scanf is going to be a real problem here. I mean, I think if nothing else, they'll just return 0. Okay. Yeah, so you can call that whatever you want, just number or num or something like that. It's just going to be the number that we operate on. Although, actually, while we're at it, you might want to declare a double also to store the result, because that will be the other thing we'll have to have in a minute here. Okay. All right. So if we go back down there, yeah. So now in your scanf line, you do scanf, and then it'll be quotes, and inside the quotes it'll be percent LF for a long float. Yep. And then after the ending quotes, do a comma and percent number to operate on. Sorry, not percent, ampersand, sorry. Yep. Okay, so that should be fine. All right, and then we just need to um, call the functions, I guess, that we. So basically, it would be we then say store the result equals. Oh no, we don't want to print yet. Sorry, we just want to like a line of code to get the result. Like so, we're gonna now run the function that they selected. So that's going to be your store the result variable.
Where?
The one that you just created on line 20. So that's going to be the result of what the next line we run. So yeah, so store the result equals.
Oh.
Yeah, and then all right. So then the syntax to like run the function pointer is a little bit weird again. So it's going to be open parentheses star, and then and let's see, what did we call our function array? We called that math array. Okay,
Yeah.
so it'll be math array. Okay, and then square brackets, and oh yeah, so then we'll need to inside the square brackets. It'll be choice. Um, this is going to be a little bit weird. Choice minus the one character. Yeah, so that'll kind of turn it from a character to an actual number. Okay, and then after the closing parentheses, we'll have another opening parentheses and put in there number to operate on. Yep, just like that. Okay, and that's good for that line. And then we can now just print out the result. Thanks. Yeah, and that'd be a percent F, I guess. And yeah, and then just remember still inside your parentheses after the quotes, do a comma and store the result because that'll actually put the result. Okay. And I think that'll be it. No, we can give it a try.
Should I just name it result?
Yeah, that's fine too. Yeah. Okay.
Now to run it.
Yep. Okay, so it's
Okay.
yeah,
Alright.
and I would pick a number that we can. Okay, that looks like that's right. 2.23 times 2.23 is about 5. Yep. So I guess you can test the others if you want, but that looks like it basically works.
Okay.
There, yeah. Yeah, I don't know what you want to do. Yeah, 15. I assume that's let's see what actually let's see log of actually I don't know the C log, is that a natural log? Let me see what the log function is in C. That's the natural log, yes. So e to the oh, I missed what the result was, 2 point something, right? Yeah, that's about right. Okay. So, oh, and which what did you do there? Was that sine?
Yeah.
Okay. And that's probably, they probably did that in radians. So sine of 30. Yeah, that's what I'm getting. Okay. Yeah. So it looks like that's all working.
And then,
Okay. So cosine of 60. Let's see, 0.95. Yep, that works. Minus 0.95. Yep, that looks like that is all correct.
is there a way for me to write something, type in your choice before the number,
Yeah, I mean, you just have to,
like
yeah, you
you
just
do
have
for
to,
this
yeah,
number?
you can just print that before the, let's see, that would be right before line, or before line 29. So basically between line 26 and 29 somewhere. Yeah, you can just print F whatever you want. Just don't put a new line before it if you want it to, if you want the input to come right after, what you wrote. Yep. Oh, you don't. Yeah, I mean, you're good. You don't need a scanf now. The get char takes care of
And
that.
that's why, because of the, yeah.
Yeah, get char is already there, so you should be good if you want
And
to
that's
try
to
that.
put
You
the
can.
new line after this, right?
What's that? Sorry.
Oh, never mind, because we hit, never mind,
Okay. Yeah.
because I forgot that the enter makes the new line happen.
Right. Yeah. The person entering their answer will have to type a new line, basically. Oh, wait a minute. What is going on there? Oh, wait. Did you compile?
Maybe,
Yeah. You might not have hit. Did you hit run again to compile it?
yeah.
Okay. Yeah.
So, 4.
Okay. Looks good.
Okay.
All right. Anything else you want to add to that one or change, or you feel like that's pretty good?
I think that's pretty good.
Okay. Cool.
Yes.
All right. So let's see. On to number 2, I guess.
Yeah.
This is write a program that creates, yeah, that one. 2 linked lists. Okay. So to write a program that creates 2 linked lists, both containing floating point values, add a function which extracts the intersection of the 2 lists, creating and returning a linked list which only contains nodes that are common to both of the original lists. All lists are simply linked. Show a menu if you feel it is appropriate. Code comments are mandatory. Huh. Okay. Uh, Interesting. Um, so I mean, yeah, it's a little bit on the vague side, but hmm. Okay, yeah, um, yeah. I mean, they're not too specific about some of this stuff. All right, well, we can copy some of this from problem 1 specifically. Well, specifically just the definition of a node. Although we'll probably want to, we can cut that down quite a bit actually. Uh, but yeah, you could copy those first few lines. So I think in that node, all you really want is yeah. In that node definition this time, I think all we really want, you can get rid of the int field type, the char text, and the unsigned int u integer. Um, and I think you can just, in addition to the struct node pointer next, I think the only other thing you need is a double or a float. They didn't really say much. I think traditionally you would probably put the double before the next. I mean, that's not strictly necessary, but normally when people do like lists, they put the data stuff first. Yeah. And then whatever you want to call it, value or number or D or whatever. Yeah. Okay. Um, yeah. So I guess we don't really they don't really talk a whole lot about the details of this. So I guess we can do it whichever way we want. Um, so I guess what I would do is hmm, I think what I would probably do is write a helper function. So let's maybe do that first. Well, actually, so let's yeah, let's do that. So why don't we write a helper function? Um, and let's see. I guess it can. How do we want to do this? Yeah, I think I mean the easiest way to work with linked lists, if they don't care about the order, which they don't say they do, is to do what we did in the other problem and like prepend things to linked lists. Um, so I think I would make this a function that returns a node pointer. So node star. Yeah. And you could call it like add node or uh, add element or something like that. Yeah. And then well, that will take in a double that you can call whatever you want to call it. It's just going to be the new value. Okay, that works. Okay. Oh, sorry. And you know what? It's going to take in two things. It'll take the double new val and it'll take a node pointer, which you can call head probably. It's going to be the head of the head. Sorry, not add, because it's going to be the head of the original head of the linked list.
Oh,
Yeah. Okay. And then yeah, that works. Okay. And then in here, I guess the first thing we're going to do is create a new node pointer. So you can say node pointer, and you can call it something like new head or something like that. And set that equal to a malloc and give the malloc size of node. Yep. Okay. And then I guess we should probably check just to make sure that we don't have a memory error. So you can say if new head equals null, then we can see. I think we did a p error for that. I think if we look back at well, we don't have to, but I'm pretty sure malloc should be a p error situation. Yeah, because that should be a system error. Yeah, that's what we did there. Or actually, well, no, that's let's see. That was more for file reading, but I think we did when we had a malloc fail, we also did a p error. Yeah, yeah, we did it there. So you can just copy that memory allocation failure and exit one if you want to.
yeah, you're getting on my nerves with the way it's formatting.
Was that sorry?
This is the formatting is getting on my nerves because
Yeah, yeah. The indentation and everything is always annoying to get right. Yeah, Visual Studio Code does not auto format it very well. Okay, yeah. So if we get this far, we know that our new node is okay. So then all we need to do is say new head arrow value equals new val. Yeah. And new head arrow next equals head of the linked list. And then we can return new head. Okay. So that's all good. All right. So then inside main, actually, let's see. Do we want to do this too? I guess we should probably do this too. If we, because I guess we should clean up our linked list at the end. So actually, maybe before we do main, we can do our other helper function, which is like to delete a linked list. Because we'll be doing this, I guess, 3 times. So this could be like a void. You'd call it like delete linked list or something like that. Yeah, and that'll take a node pointer, which you can call head or something like that. Okay, and actually, what you could probably do is copy, like if you go back to problem 1, just go down to the bottom of the screen or the code file where we, yeah, all the way down. Okay, yeah, so right lines 122 through 126 there, you could pretty much just copy, and yeah, that's going to basically be the basis of our function. And the only thing I think you need to do here is before that while loop, make a node pointer called temp. Yeah, that's, you don't even have to set it equal to, yeah, that's fine. But yeah, either way is fine. And let's see, well, head is not equal to temp equals head equals header next free temp. Yep, that looks good. Okay, so that'll be useful because this time we'll be eventually freeing 3 linked lists. So that'll save us some lines of code. Okay, so now I think finally we're ready to do main. Um, so yeah, so I guess you'll want to make a node pointer. You can call it, I don't know, head 1 or something like that, because you're going to have two linked lists. So whatever you want to call that. Yeah, and then basically you can say head 1 equals, and let's see, what do we call our add value function? Something like add value to list or whatever you called that one, or add node. Yeah, so add node, and then just enter some number, some floating point number. I mean, they say like we just need to create 2 linked lists, both containing floating point values. So I guess, yeah, you just put in some floating point value, or put in a floating point value. Yeah, so add node, you put in the number, and then a comma, and then head 1. Yeah. And then basically just repeat that line several times, as just make copies of that line and change the numbers however many times you want for however many numbers you want in the list. Probably 4 or 5 is plenty. Yeah. Okay. And then basically you want to just copy all of those head 1 lines, 34 through 39, and make a second copy of that, but just change head 1 to head 2, and we'll change some of the numbers because basically you know you want the 2 lists to have some members in column but not all members. Yeah. So then you can just change head 1 to head 2. Yep, and then change some of those numbers to be different. So you want some of them to be the same, but other ones you want to. intersect. So yeah, leave 2 or 3 of them the same, I guess, and 2 or 3 of them different. Okay, looks good. All right, that's good, I think. Okay. All right, so now we get to do the fun stuff. So we get to create and return a linked list, or we need to extract the intersection of the two lists and create and return a linked list. It only contains those that are common to both the original lists. Okay, so I guess what we're going to need here is a nested for loop. So let me think about this. Yeah, so I think this is going to be kind of one of these weird like linked list for loops. So in the for loop, we'll say like node pointer. You probably call it I or whatever if you want, like a normal for loop variable. But yeah, and that's going to equal head one. And this is going to be a little bit weird. I not equal to null. Oh, I just realized something. Yep. And then I equals I arrow next. I just realized that on line 34 and 35, we should initialize head one and head two to null. Yeah, because that will be important for how the linked list stuff works. Okay, good. All right, cool. All right. And then in there, yeah, I think we want to have another nested for loop that is basically exactly the same as the line above it, but it'll be the node pointer will be, J, and it'll start off equal to head two instead of head one. Yeah, exactly. Oh, and up where you create your head one and head two, probably we need to create another node pointer. So like after line 35, probably want to create another node pointer, call it something like intersection to hold the intersection of the two lists. Okay. All right. So then now they're a little bit weird here. So they say this is a little bit strange. They say be careful when comparing floating point numbers. I assume that means they maybe want to basically see if the numbers are the same within some tolerance rather than being like literally exactly equal. Is that something they've like taught about in your classes, or have they talked about that?
I don't know.
Okay, yeah, I mean, yeah, I have to assume that's kind of what they're getting at with that. So what we might want to do is up at the top of the function, you might want to declare a double variable called something like tolerance, or sometimes people call it epsilon. Um, yeah, and set that equal to what's that? Yeah, exactly. And they set that to some small number like 1e minus 10 or something like that, or 1e minus 12 or something. Yeah. So that's basically like how close two floating point numbers can be and still be considered the same. Oh, and while I'm thinking about it, I'm kind of just thinking ahead. I think we need to include math.h at the top because we're going to need the floating point absolute value if we are comparing stuff that way. Yep. Yeah. Okay, cool. Okay, so now in here, I think we're ready. And I think what we can do is say if f abs Oh, wait,
What?
you just lost your for loops. Yep. Yeah. So if fabs of I arrow, what do we call the value? Do we call it value or something else?
Yeah.
Value.
Yeah. Okay. Minus j arrow value. Yep. So yeah, then after your parentheses is less than epsilon, then that's a value that is for our purposes considered the same. So you can say yeah. So then you can say your intersection node pointer, whatever you call that intersection of the whatever you call it, intersection of something something. Um, yeah. Okay. So that equals add node, and then you give that I arrow value and a comma and intersection of the two lists. And then yeah, intersection of the two lists would be the second parameter to add node.
Oh.
Okay, cool. All right. And what I would do, they didn't really say this, but this is just seems logical to me. Is I think you could also after that line, um, this is yeah. I mean, you could interpret this various ways, but I would do a break at this point because you've already found that number is in the lists once. I mean, this is I'm not going to like completely guard against duplicates, but it'll be better than nothing for duplicates. I mean, I don't. They didn't say not to have duplicates, so I guess it doesn't really matter. Actually, you know what? I take that back. Maybe let's not do the break because that's just going to open a small can of worms. So I would say actually let's not worry about the break. Let's not worry about duplicate numbers unless you think they care. I mean, in other words, like if both of the lists have, let me think about this. Yeah, if the lists have duplicate values, like the intersection will also end up with duplicate values, but they didn't say what to do in that case, so I guess we don't have to worry about it. Okay, and then I think we're mostly done. Now they didn't really say this, but I guess you probably want to display some output just to like prove that it works. I don't know. So if you want to do that, we can after line 59, we can have another little for loop, or actually probably what you want to do is like maybe before the for loop print out something like here's the intersection or whatever you want to say. Yeah. Yeah, and then you could do yeah, for node pointer I. Yeah, you could kind of do that basically. It's going to be node pointer I equals intersection of the two lists. Okay. And then I not equal to null. And then I equals I arrow next. Yep. And then you could f printf, or sorry, not f printf, just printf. Um, and then I guess the format string would be something like %f and probably just a space. That would be the easiest thing to do. or a new line, depending on whichever you prefer, I guess, whether you want spaces or new lines. Yeah. Okay, and then yeah, and then after that, that would be I arrow value. Yeah, that's good. And then after the for loop, I guess all we have to do is delete our 3 linked lists. So we made that helper function already. What do we call it? Delete linked list. So yeah, just call it delete linked list and give it head 1. And then delete linked list of head 2. And delete linked list of intersection of the 2 lists. Okay, and I think that's pretty much it. I think you can try to run it and make sure that works.
Didn't it say something about a menu?
They say if you feel it's appropriate. I don't know why you would.
That's
But
fine. I
yeah,
don't care.
yeah,
I think
okay.
I know. I think I remember this code. I got it at a test one time. I
Okay.
think there was a menu for deleting, for adding. It's fine. And an intersection, but it's not needed.
Okay. Yeah, I'm not sure like why they would be asking for a menu, with what they said there. So okay, that looks like it worked. Those are
Just
the
to
2
see that
numbers.
it yeah. That we know how to do menus.
Yeah. Yeah, I mean, we can add more to it if you want. I don't know. When they say if you feel it's
Maybe
appropriate, I'm like,
later.
okay. Yeah. I mean, this has the core functionality they asked for about the. You got 2 linked lists containing floating point values. You added a function that extracts the intersection of the 2 lists, creates and returns a linked list. Which link contains nodes? Actually, well, okay. I guess it depends. I didn't think about this. I guess they do say add a function which extracts the intersection of 2 lists, creating and returning a linked list. Maybe if we want to be in the letter of the law, we maybe should put some of that main code into a standalone. They do say create a function or add a function. So maybe we should actually, if we want to be really good, like move that double loop inside main to its own function. So yeah, if you want to kind of maybe cut that out, yeah, we can move that into its own function. Yeah, so you could call that, so I guess that would be return a node pointer. Um, yeah, and you
What
could
was
call it
that?
like intersection or something like that. Yeah, and paste in that, and then that function should take. Well, yeah, if you want to keep it easy to cut paste your code, you can just give it 2 input parameters and call them head 1 and head 2. So node star head 1 and node star head 2. But sorry, you still want them where you had them. Yeah, so I mean that's fine. You can paste in there, but you will also want them
Okay.
back where they were. Yeah. Yep. And then okay, and then yeah, and then I guess at the top of that function, like right after line 34, we should declare a node pointer, which if you're naming it the same, yeah, you could just call it intersection of the 2 lists if you want to keep it consistent. Yeah, and set that equal to null initially. Yeah. Okay, and then I think all you have to do is after line 43, you just return intersection of the 2 lists. Yep. And then down in main, all we have to do is say, let's see. So after line 63, before line 65, yeah, we can say intersection of the 2 lists equals equals linked list intersection or whatever you call that. And then give that node 1 and node 2, or head 1 and head 2 rather. Okay. That should still work the same way, but you probably want to run that and just make sure nothing changed.
So if he would want a menu, this would be an option, this would be an option, and then this would be an option, like deleting.
I guess, yeah. I mean, it seems like an odd, doesn't seem like a programming demonstration that really lends itself to a menu. But you want to actually make sure it compiles again. Okay, wait a minute. Unused variable. Oh, sorry. That epsilon should go. We should move the epsilon up to the
one that we created.
The function, yeah. Okay, yeah. Let's try compiling that again. What is going on? Oh, linked list intersections. I think you need an S after the end of the name. Yeah, on line 66. Yeah. Okay, yeah. Now we're back to normal. All right, cool. Okay.
Okay.
All right, cool. All right, want to keep going?
Can we do another day?
Yeah, yes. When did you say this is actually due?
It's due technically today, but no one's going to turn it in today. It's not
Okay.
our grade. It's just review.
Okay,
Which we did the first 3, and that's what we're gonna go over anyway.
Okay. Yeah, I was gonna say because the only catch is I'm looking for my next availability would be, and let's see, because tomorrow's Thanksgiving, and I mean I've got some appointments tomorrow, but I'm filled up that day. Friday is full. Saturday is probably full. Sunday, I mean, I might have some cancellations and stuff, but I don't know that for sure yet. I would have an. Oh, let me actually check and see if I've got any incoming messages from anyone that took. Okay. Yeah, so I've got an hour free on Monday, or I could do like nighttime on Monday. So yeah, anyway, so my next availability would probably be Monday, essentially.
Okay.
I don't
Around
know if
what times? You said morning.
Well, it would be
or not morning, during
I
the
could
day.
do an hour at 1:15 Pacific, or I could do 9 p.m. Pacific.
I'm thinking. Let's do 9 p.m. Pacific.
Okay. All right. Sounds good. Let me just copy that over. All right. So 9 p.m. Pacific on Monday for the next batch.
Can I take both spots?
Yeah, if you think you can make. Yeah. So you think you are available at 1:15 on Monday?
Yeah.
Okay. Yeah. Let me put that in. Okay. So I've got you in 1:15 Pacific. Oops. All right. So that's. Here we go. Okay. Yeah. So I've got you 1:15 and 9 p.m. on Monday the 28th.
Yeah.
Okay. Sounds good. I will get those set up. All right. Anything else, or does that take care of you for tonight?
That'll take care.
Okay, sounds good. All right. Well, in that case, have a good one. Happy Thanksgiving if you celebrate, and
Thank you as well.
yep.
Yeah,
And I'll see you on Monday, I guess.
you too.
All right. Thanks so
Bye.
much. Bye.